Hey guys, welcome to a level 2 graphs internal practice. Okay, so for this video I'm going to be walking through task C on the TKI internal website. Okay, so if you go onto the TKI website, you go to level 2 maths, you scroll down to 2.2 and then you go down to task C. You should find this task. Okay, I'm going to just walk through this task in this video. Alright, part 1. A symmetrical bridge is being designed to cross a river. A sketch of half of the bridge design is shown on the graph opposite. The maximum height of the bridge is 12 meters and the total length is 60 meters. The shape of this section of the bridge could be modeled by any of these functions: a parabola, trigonometric function, cubic, square root, or hyperbola. Draw graphs of at least 3 different functions that could be used to model the half bridge as shown. Give the equation of the function used in each model. Discuss the features or properties for each of the functions you have developed. Okay, so this is basically just using 3 different graphs to model the same shape. Okay, the same graph. Okay, so the easiest 3 I can think of, I'd probably choose do a parabola, a square root, and a hyperbola. In my opinion, I think those would be the easiest to do given what information we've been given. Because we've only been given 2 points. We've been given that the maximum height here is 12 meters, and this occurs. The whole thing is 60 meters, so therefore the max height will occur at 30 meters, and we know that this point is 0, 0. Okay. Alright, I'm gonna go to separate document. Okay, I'm gonna go just blank document. Okay, so I'm gonna model a parabola. Okay, so we are going. Oh, sorry, that's bad writing. We are going to model a parabola. Remember, communication is very important. You have to communicate to the marker of what you're doing during the internal. Okay, so so the equation of a parabola, we can use y equals to a, x minus h on x minus f. Okay, h and f are the x-intercepts. Okay, so if I just draw a mini sketch of what we just had before. Oh, that's terrible. If we mini sketch of what we had before should look something like this. Yeah, sorry, it's a pretty bad drawing, but it looks something like this. Okay, so we know that this intercept is 0, 0, and if we kept going, this intercept will be 0, 60. 60, 0. So 60, 0. Okay. So we're going to use the x-intercept equation. We're going to substitute 0 and 60. Okay. We're going to say that y equals to a x minus 60. Okay, and now we're going to substitute the point, the vertex point. Okay, that's here. So that point is should be 12, no, other way, 30, 12. Okay, so when the bridge at the middle of the bridge, the height is 30 meters. Okay, so basically that's what it is. So we're gonna say that 12 equals to a 30 minus 60. So therefore 12 equals to a negative 900. 12 equals to negative 900a. Therefore a equals to 12 divided by negative 900. Okay, so therefore your equation will be y equals to negative 12 over 900 x minus 60. Okay, for this question you could also use the vertex equation. I'm going to show you that as well, the vertex equation. So that's y equals to ax minus b whole squared plus c. B and C, they're the coordinates of our vertex. Okay, so our vertex would be 30, 12 here. Okay, so we're just gonna plug it in. So we're gonna say y equals to a x minus 30 whole squared plus 12. Y equals and then we're gonna substitute one more point. Okay, we're gonna substitute we're gonna substitute 0, 0 here. Okay, so we're gonna say 0 equals to a 0 minus 30 whole squared plus 12. 0 equals to a negative 30 whole squared plus 12. 0 equals to negative 900a, positive 900a plus 12. we move the 12 to the other side, so negative 12 equals to 900a. Therefore, a once again equals to negative 12 over 900. So if we can rewrite your equation as y equals to negative 12 over 900 x minus 30 whole squared plus 12. So both of these equations will be accepted, okay? So moving on to the features of the graph. Features. Our features will have our domain. Okay, because this is only half the bridge, okay? It's only half the bridge, so therefore x should start at 30. No, should start at 0 and end at 30, okay? So x is greater than or equal to 0 and less than or equal to 30, okay? It starts at 0 and ends at 30. Our range, okay? Our range is our highest point is 12 and our lowest point is 0, okay? So y is greater than or equal to 0 or y is less than or equal to 12. Alright, we have our x-intercepts. Okay, our x-intercept is at 0, 0. And we have y-intercept. Well, okay, our only x-intercept is 0, 0 because we restricted our domain from x is between 0 and 30, so therefore the x-intercept of x equals to 60, that doesn't exist because our domain has been restricted, okay? So y-intercept, okay, that's once again 0, 0. And our vertex is simply 30, 12 here. Okay, so that's our parabola done, okay? Pretty straightforward, okay? So we'll move on to doing hyperbola, okay? So I will model the graph with a hyperbola, okay? So I'm gonna sketch out the graph again, okay? It should look something like this. Okay, so notice if we kept continuing the hyperbola, it should look something like this, okay? We don't know what the asymbiot is, but take a rough guess, rough estimate, okay? We're just gonna take a rough estimate that we'll say rough estimate. That's not how you spell estimate. That's rough estimate. Rough estimate of the rough intercept of the vertical asymbiot, okay? We'll say that it's been shifted 1 unit left, okay? So therefore, our standard equation is y equals to k divided by x minus b plus k, not k, sorry, we'll just say plus c, okay? So we're going to assume that the parabola has been shifted left by 1 unit. So therefore, y equals to k x plus 1 plus c, okay? So now we're going to use simultaneous equations to solve for the hyperbola. Okay, so we know that when x equals to 30, y equals to 12. And we also know when x equals to 0, y equals to 0, okay? So say 0 equals to k, 0 plus 1 plus c. And we also say that 12 equals to k, 31 plus c, okay? So we're going to say 0 equals to k plus c, and we'll say 12 equals to k divided by 31 plus c. Okay, so we're going to say that 12 minus 0 equals to k plus c. Oh no, wrong way. We'll say that k divided by 31 plus c minus k plus c, okay? So 12 equals to k divided by 31 plus c minus k minus c. The c's are gone, so therefore 12 equals to k divided by 31 minus k over 1, okay? So therefore we'll have 12 equals to k divided by 31 minus 31 k over 31. Therefore 12 equals to negative 30k over 31. So 31 times 12 equals to negative 30k. Okay, if we get a calculator, so 31 times 12 is 372, divided by negative 30 should give us our k. And our k gives us to be negative 12.4. Okay, so because 0 equals to k plus c, 0 equals to k plus c. Okay, so therefore we found our k is negative 12.4. So 0 equals to negative 12.4 plus c. C, as you can see, must be positive. Must be positive 12.4. Okay, so we'll say that c equals to 12.4. Okay, so we rewrite our final equation. Okay, we'll rewrite our final equation. So we'll say y equals to 12.4 divided by x plus 1 plus 12.4. Okay, so that should be your oh no, not 12, it's negative 12, sorry. Negative 12.4 divided by x plus 1 plus 12.4 should be your final answer here. So if we go on to the features of the graph, okay, features of the hyperbola. Features of our domain, that should be the exact same as our parabola. Starts at the same place, ends at the same place. So we say x is greater than equal to 0 or less than or equal to 30. Range is also the same. Okay, y is greater than equal to 0, y is less than or equal to 12. We'll say that the x-intercept is 0, 0, which is the same. Y-intercept is the same, 0, 0. Okay, now we have our horizontal asymptote, okay, whatever you want to pronounce it. So we'll say that that y equals to 12.4, and we'll say that our vertical asymptote that equals to x equals to -1. Okay, so that should be your features for your hyperbola. Okay, and we'll go on to the square root graph. Okay, so we'll get another blank page hopefully. Sorry, just ignore the stuff at the top. Okay, ignore. Sorry. Okay, so we know that y equals to k times square root of x. Okay, and once again we have our draw simulation of our graph. Should look something like this. Okay, this point here is 12. Wrong way again. Sorry. Wrong way. 30, 12. Okay, and this point is 0, 0. Okay, so it's we'll just substitute a point in to find our k value. Okay, so we'll say that 12 equals to k times square root of 30. So k therefore equals to 12 divided by square root of 30. So therefore we'll say that y equals to 12 divided by square root of 30 times square root of x. Okay, so that's pretty simple and straightforward. Okay, so that's your equation. Okay, moving on to the features of the graph. Okay, so we'll say domain once again is the same. Okay, there should be no change. Same graph for the parabola, same graph. So x is greater than or equal to 0, less than or equal to 30. Range is the same. Y is greater than or equal to 0, less than or equal to 12. And x-intercept, same. X-intercepts 0, 0. Y-intercept 0, 0. Okay, and now that's it for the square root equation. That's probably the easiest one out of all of them. Like, there's not much to it. Okay, so we're going to be moving on to task number 2 now. Okay, which will be in another video because I'm really paranoid that my video will get cut off. Okay, so apologies for that. Okay, so this task will be split into 3 separate videos. Okay, hope you understand. Okay, so I'll see you in the next video. It will be out very shortly.